Okay, so in this video I'm going to have a look at factorials. So you may have noticed on your calculator there's a button with this kind of exclamation mark on it. This is the button you can use to work out factorials. So to give you an idea of what a factorial is, if you take, for example, 4 factorial, so you just press 4 on your calculator, press this button here, press equals, and what you'll actually get is 24 as an answer. So how did they get that? Well, 4 factorial is really just 4 times 3 times 2 times 1. So you just take the number and multiply each number less than it down as far as 1. So if you do that, you get 3 4s 12, 2 12s 24. So similarly, 6 factorial is just 6 times 5 times 4 times 3 times 2 times 1. So that's 720. Okay, so if you want to let's say multiply factorials, so let's say you have 3 factorial multiplied by 4 factorial, so that's just simply 3 times, well actually, you know, what we might do here is add them first. We'll try adding them first, okay, rather than multiplying. So we'll take 3 times 2 times 1, so you're just going to add that to 4 times 3 times 2 times 1. So 3 factorial, 3 times 2 times 1 is just 6, and then 3 times 4 is 12, 2 12 is 24, so that's our 4 factorial. Add those two together and you get 30. So again, your calculator will do this for you, but this is how you would do it manually. Okay, so let's have a look at multiplying them then. Same kind of thing again. 3 factorial multiplied by 4 factorial. Well, again, that's just simply 3 times 2 times 1, all multiplied by 4 times 3 times 2 times 1. So again, that's 6 times, and this is 24 again. That'll give you 144. Okay, so let's try dividing now. So we've done addition, multiplying. Subtraction is the same, by the way. You just subtract. Instead of adding here, you would just subtract. So let's have a look at dividing then, dividing factorials. So let's take, for example, 9 factorial divided by 7 factorial. Well, if you work this out on your calculator, that's just going to be 9 times 8 times 7 times 6 and so on down to 1. You get 362,880, 362,880. And 7 factorial, which is 7 times 6 times 5 times 4 times 3 times 2 times 1, is 5,040. And if you work that out, you'll get 72. Now another way of looking at this is if you have 9 factorial divided by 7 factorial, you can see here 7 is less than 9. So what is 9 factorial? Well, 9 factorial is just 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Now if we divide that by 7 factorial, which is just 7 times 6 times 5 times 4 times 3 times 2 times 1, you can see what we can do here. Everything on the top here is multiplied, everything on the bottom is multiplied here. So you can actually see that this 7 will divide by this 7, 6 will divide by 6, 5 will divide by 5, 4 will divide by 4, and so on. And what we're actually left with here is just simply 9 times 8, which is 72. So really, when you're doing something like this, you don't necessarily have to do all of this stuff here. What you can do is take 9 factorial, divide by 7 factorial. Really with the 9 here, the larger number, it doesn't matter whether it's on the top or the bottom, just go down as far as the 7. So it's 9 times 8, and then it's really just 7 factorial. From here to here is just 7 factorial. So we don't have to write it all out. On the bottom here we've got 7 factorial. Again, we don't have to write all that out, but you can see here that this 7 will divide by this 7 factorial will divide by this 7 factorial here, and again we just get 8 times 9, which is 72. Okay, so very often you're not necessarily going to be dealing with numbers. You're going to have a look at this in terms of algebra. So let's look at our basic definition of a factorial in terms of, we'll use the letter n here, n factorial. What is n factorial? Well, we've seen that 4 factorial is 4 times 3 times 2 times 1 and so on. Well, n factorial is just going to be n times 1 less than it, 1 less than n, which is n minus 1, times 1 less than that again, so that's going to be n minus 2, 1 less than that again, n minus 3, times all the way down to, we'll say 3 times 2 times 1. So there are an infinite number of algebraic terms, if you like, in the middle here, depending on what n is. So for example, if you take, if we don't take n, let's say we take n plus 3 factorial. Well, that's just n plus 3 multiplied by 1 less than n plus 3, which is n plus 2, times 1 less than n plus 2, which is n plus 1, times n, which is 1 less than that again, and so on, n minus 1, times all the way down again to 3 times 2 times 1. Okay, so let's have a look at some algebraic kind of calculations that we can do using factorials. So let's take, I'm just going to do a few examples. So let's take n plus 1 factorial. We're going to divide that by n factorial. So how would you do this? Well, similar to the one we did earlier using numbers, 9 factorial over 7 factorial, that's the way I'm going to do it. So I'm going to take n plus 1 factorial. That's going to be n plus 1 times 1 less than it factorial divided by n factorial. So it's n plus 1 times n minus 1 times n minus 2 times n minus 3 and so on, which is really all just n factorial. On the bottom we have an n factorial, so we can just divide these two. We'll get 1. So on the top here we'll just end up with n plus 1. Okay, let's have a look at another one. Let's take n plus 5, for example, n plus 5 factorial, and let's divide that by n plus 2 factorial. Well, we can see the larger numbers here on the top, so let's go down as far as n plus 2 factorial. So n plus 5 factorial is n plus 5 times n plus 4 times n plus 3 times n plus 2 factorial, all divided by n plus 2 factorial. So I stopped at the top here at n plus 2 factorial because that's what I've got at the bottom here, and I know that I can divide that into that to give me 1. So on the top I'll end up with n plus 5 times n plus 4 times n plus 3. So I've gotten rid of all my factorials here and I've just ended up with this here, which I can multiply out to get a cubic expression here, but I won't do that. But this is effectively what I get if I divide this n plus 5 factorial by n plus 2 factorial. Okay, so let's try another one. Let's try where we have the larger number on the bottom. So let's try n minus 2 factorial on the top, and let's say n plus 1 factorial on the bottom as our denominator. Now in this particular case, what I'm going to do is take the larger one and bring it down as far as the smaller one. So I'm going to leave the smaller one, the one on top, alone. I'm going to leave that as it is. The one on the bottom then is n plus 1 times 1 less than n plus 1, which is n, times 1 less than that again, which is n minus 1. And now I'm actually down as far as n minus 2 factorial. So again, here you can see I can divide that by that to give me 1, and I end up with 1 on the top and n plus 1 times n minus 1 on the bottom. So again, I've gotten rid of all the factorials here, so I don't have to worry about any factorials anymore. I can multiply out the denominator here if I want to. Okay, so as an example, a numerical example of that, I'll just leave that there actually. If you have, let's say, 8 factorial divided by 11 factorial, we'll take the larger one, the one on the bottom. That's going to be 11 times 10 times 9 times 8 factorial. So we can see here I can divide that 8 factorial by that 8 factorial there. So I'll just simply get 1 on the top and 11 times 10 times 9 on the bottom. So that will give me 1 over 990. Okay, so let's have a look at another one. Let's take 3n plus 1. 3n plus 1 factorial on the top. And let's just take 3n factorial on the bottom. Okay, so I'm going to need to look at the top one and reduce that. So I have 3n plus 1 times 1 less than 3n plus 1 is just 3n. Now I have a 3n on the bottom here, so I'm going to stop there and put in my factorial there. So I have 3n factorial on the bottom. That will divide into that there, and I just end up with 3n plus 1 on the top. Okay, so I'm going to do one more. Now this is a question that came up in an exam paper recently, so I'll write it out first. So it was find the letters A, B, C and D if n plus 3 factorial times n plus 2 factorial divided by n plus 1 factorial times n plus 1 factorial is equal to an cubed plus bn squared plus cn plus d. So really I have a cubic expression on the right, and I have this thing here on the left, which presumably will reduce down. If I mess around with this a little bit, I'll end up with a cubic expression as well. What I can do then is just equate the coefficients. Just have a look at the numbers in front of the variables n and this d here as well, the term independent of n, and equate the coefficients. So let's see how we're going to do that. Well, I can see here on the top I've got an n plus 3 factorial and an n plus 2 factorial. Down at the bottom here I've got an n plus 1 and an n plus 1 factorial here, which is actually, these two are lower than these two here, so I can reduce these down to n plus 1 factorial. So in other words, this n plus 3 factorial here, I can write it as n plus 3 times n plus 2 times n plus 1 factorial. This n plus 2 factorial I can write as n plus 2 times n plus 1 factorial. And the reason I stopped there is because I've got an n plus 1 factorial times an n plus 1 factorial on the bottom. You can see, because everything is multiplied on the top and the bottom here, I can divide this one into this one here. I can divide this n plus 1 factorial into this n plus 1 factorial here, and that gets rid of all these factorials. So underneath here, what am I left with? I've got an n plus 3 times an n plus 2 times an n plus 2. There are no factorials here anymore that I have to worry about. On the right hand side I've still got an cubed plus bn squared plus cn plus d. Now you can see on the left hand side here, this will become, it's a cubic expression. So I'm just going to multiply it all out. So if I multiply these two out first, I get n squared. So I get n squared here. Just move that over here. N squared plus 5n plus 6. So all I've done here is multiplied out these two here, and I'm multiplying that by n plus 2. I'm saying that's equal to all of this. Next thing I'm going to do is I'm just going to take this n plus 2 and multiply it by this quadratic here. So if I do that, I get n cubed. Whoops. I get n cubed plus 5n squared plus 6n plus 2n squared plus 10n plus 12, and again that's equal to all of this here. I won't write it out. So if we simplify that, then we have an n cubed plus there are no other n cubes there, so it's just n cubed. We have a 5n squared here, and we have a 2n squared here, so that will give me a plus 7n squared. We have a 6n here, and we have a 10n here, so that will give me 16n. And then finally at the end here we have a 12. And remember, that's all equal to an cubed plus bn squared plus cn plus d. So now at this stage we've reduced down the left hand side to this cubic expression. The right hand side is a cubic expression. So now we can start equating coefficients. So we can see here there's a 1 here in front of the n cubed, there's an a here in front of the n cubed, so we can say a is equal to 1. We can see here we've got a plus 7 in front of the n squared and a plus b here, so we can say b is equal to plus 7. We have a plus 16 here in front of the n and a plus c here in front of the n, so we can say c is plus 16. And finally here the term independent of n, d, is going to be equal to 12. And that's it really for this video on factorials.